conditions that can confine or define the energy level. The conditions would be, the charge of the nucleus, other electrons in the atom, and whether the atom is in bonding to another atom. So for just a atom in the gas phase by itself, orbital is the shape of the electron, and two electrons can share this shape if they have opposite electron spins. An orbital does not have a specific boundary, does not have a specific radius. We do not know how the electron really moves within this orbital, but we can describe it with a probability distribution given to us by psi squared, the wave function squared. This wave function squared gives us our probability distribution. We can give it as a function of the radius. We can give it a three-dimensional probability distribution. We normally show a boundary surface as our primary way of showing the orbitals. This surface will contain about 90% of the electron density. We cannot show a surface that shows 100% of the electron. The electron can extend very far away from the atom to some small percentage. So we show a boundary surface that shows 90% of the electron density. And what that also will show are nodes or changes of phases. If we have multiple lobes on our orbital, those will usually be different phase of the electron. The electron is a wave, just like waves on water. They have peaks and troughs. Well, if two peaks meet, then the electron has constructive interference and exists in that area. If two troughs peak, it has constructive interference and exists in that area. But if a peak and a trough meet, or between a peak and a trough, there is destructive interference, and the probability of finding the electron goes to 0. That is called a node. So when we have a surface, which can be a plane, a cone, or some other shape, when we have a surface where the probability goes to 0, it's called a node. And this node is separating the two phases of the electron wave, the peak and the trough phase of the electron wave. The primary shape given to us is given to us by the sublevel. So the sublevel gives us the primary shape. So for S is spherical. The shape of S does depend on whether it's 1s, 2s, 3s. So 1s is a spherical shape with no nodes. No nodes, that means it's one phase only. It's the peak only, no trough. How can you have a peak without a trough? That will oscillate in time, but in space we only see one at a time. This is like the fundamental node on a vibrating string. It is all up or it's all down at one time. This is the 1s orbital. The 2s orbital, this will have a node in it. It will have one node in it. So it's a sphere inside a sphere. So in between those two spheres will be a spherical node, nodal surface. So if we said the outside sphere is our peak, the inside sphere is our trough, and in those is the spherical node between those two surfaces. 3s, we add on one more sphere, layer of the onion. We add on one more node. So 3s has 3 layers to it. Each layer is a different phase, so we can have a peak on the outside, trough in the middle, and a peak on the inside. In between each of these, we have a nodal surface. So we have 2 nodal surfaces to correspond with our 3 lobes to the 3s. And this process will continue. When we go to 4s, 5s, we add a layer and a node each time. For the p sublevel, each orbital is 2 lobes. Those are the 2 phases of the electron wave. So it's the peak and the trough on opposite sides of the nucleus. So in between these is going to be a planar surface. So for the 2px here, which has the lobes aligned on the x-axis, the yz plane is going to be a node. So the probability of finding the electron goes to 0 on that yp plane. So the 2 sides of the x are the 2 phases of the electron wave. So for 2p we have these simple lobes. They all fit together to form an overall set. And the overall set becomes roughly spherical. When we go up to 3p, we're going to get a double lobe on each side of this. And in between those is going to be a node. So we're going to have, for each orbital, we're going to have 4 lobes and 3 nodes. So 3 surfaces where the probability goes to 0, 4 areas of electron density with alternating signs of the electron wave. And this continues the process as we go up to 4p, 5p. Each time we add another layer onto each of the lobes together. For D, we start off with 3D. 3D, we're going to have a 4-lobe orbital. So these 4 lobes are alternating in phase, a peak, trough, peak, trough. In between them is going to be surfaces. So we're going to have 2 surfaces that have nodes to them, nodal surfaces, where the electron density goes down to 0. So we give our d orbitals series of names here, d, y, z, for the lobes on the yz plane, d, xz on the xz plane, dxy on the xy plane, and these are between the axis of the planes, the axis of the coordinate systems, and then dx squared minus y squared, which is on the xy plane, rotated 45 degrees from dxy, so this one is lined up with the xy coordinate system. And then dz squared, which is on the z-axis. And this one's a little different. This one has 3 lobes to it. It's as if 2 central lobes just blended together. So we're going to have a 3 lobes. We still have the 2 nodal surfaces. 2 surfaces where the electron density goes to 0. Those surfaces are no longer a plane like they are for the other 4 orbitals, but these are conical surfaces pointing up and pointing down, separating the 2 dumbbell-shaped lobes from the donut torus shape lobe in between. And when we go up to higher d orbitals, like 4d, we're going to do as we did before. We're going to add a layer inside each of the current lobes. So each of the current lobes will become a double lobe. Looks like I have not put in our 4F orbitals yet. 4F contain 8 lobes. And I will put these in. For hydrogen alone, the orbital energies are determined only by the value of n, the principal quantum number. So all values of n have the same energy, which means they are called to be degenerate. When we have multiple electron atoms, the energy of the orbital is affected by the value of L also, so by the sublevel also. So we have the principal energy level and we also have the sublevel. So for a value of n, one value of n, we see that the energy of the sublevel increases with values of L. So P is higher in energy than S, D is higher in energy than P, and F is higher energy than D. If all the electrons are in the lowest possible state, we are in ground state. If some electrons are in a higher state, that means there's empty states underneath them, then they are excited electrons, excited state electrons. And we said this already. So for a particular n, the S sublevel has the lowest energy. P is next higher in energy, then D, and then F. Here's our equation list, which means that we are at the end of this chapter, along with our constants.